Welcome to Quant 10's Inherit Calibration Curve. Inherit calibration curve is useful when you're running suspects, meaning you don't have any standard. Nevertheless, you can reuse other targets' calibration curves. Now the suspect has an estimated concentration within an order of magnitude based on the original reference target. Let's look at the relationship between targets and suspects, because suspects are just like targets, except they inherit the calibration curve. The user interface provides a couple of visual cues. First, the calibration curve is dotted line, and the suspects are grayed out for final concentration, where the targets are not. Okay, let's take a look from the method editor. We'll come back and look in more detail here. But we're going to analyze here and take a look in batch at a glance. So in batch at a glance, we can see that there's the target, and that's what we've used as the reference calibration curve. And you see that in a solid line. As we go over to the suspects and the relationship to the target, which we set up in the method editor, you'll see that there's a dotted line there, and that is the same exact calibration curve, which is shared with all of the suspects that have inherited that calibration curve. Let's go back and look at how to set that up in the method editor. First, we'll look here at the advanced tasks, and there you see the inherit calibration reference setup, and that is the relationship between the target, the calibration reference compound. They're all targets, but we're going to create those targets that are suspects by creating a relationship back to a target so that it inherits that calibration curve. So for the demo, we're going to go to the advanced tasks and set up the calibration reference. And I'm going to use 1,1,1-trichloroethane as the reference calibration compound. And I will set up the suspects to inherit from that by creating a relationship similar to an internal standard, a relationship between the target and the suspect. So you'll see that calibration inheritance behavior.
Thanks for your attention.